In section 7.6, we're going to revisit the percent discussion that we had earlier. So we started looking at percent using multiple models, different models, including the percent thermometer. And that discussion happened in section 2.5 and Math 112. And I've asked you to review that if you did not take Math 112 with me or if you needed a refresher. So for section 7.6, again, with the textbook, you will be able to see multiple models, and I'm going to introduce another one through the discussions here. And that's going to continue being the percent thermometer. So section 7.6, activity 7p, gives you two pairs of examples. In the first pair, a carton of milk is going from $2 to $3, and a box of laundry detergent went from $5 to $6. If you notice, both of those situations, we have an increase of $1. But it seems like those are not exactly the same situations. There's a difference there. Even though they went up by $1, there's a feeling of substantial difference. And I can add a third one, for example. If the price of a car went up by $1, that would still be an increase of $1, but still it would feel rather different. Let's take a look at the percent thermometers. So we're going to draw two percent thermometers. And for one of them, it's going to be for milk. And the second one is going to be for laundry detergent. The milk went from $2 to $3. The laundry detergent went from $5 to $6. Okay, so it looks like this absolute difference, this difference here, is actually the same. It's $1. But that $1 seems to be making a bigger difference, right, in the milk rather than the laundry detergent, because it is a bigger portion of how much the original cost was. And if you remember, I was suggesting a car, the cost of the car is so high that $1 change is not going to make any difference at all. That red section is going to be so big that the blue section, which is still going to stay at $1, is going to be almost not noticeable. Now, if we were actually to look at, well, how do we express that dollar? Well, we can say that if 2 was the original price of the milk, and that was 100%, then the $1 is actually 50%. So this $3 is going to be going to 150%. For the laundry detergent, that same $1 is not going to be as big as 50%. In fact, it's going to be a fifth of the cost. So it's only going to be 20% of the cost of the laundry detergent. So that $6 price is going to be 120%. So you notice that what's happening when we talk about the price, that's the absolute difference. The price went up by $1, but on the left side, when we're actually looking at what percent that is of the original price, we see that that absolute difference of $1 is actually quite dramatically different for the two situations. Let's look at the second situation. We have two sizes of makeup, small and large. And for the small tube, we had $10 initial price, and it went up to $15. And for the large, we had $20. It went up to $30. So if we look at what the differences are, in the small tube, it went up by $5. In the large tube, it went up by $10. And we would say the price of the large tube actually increased a lot more. In the absolute change, it went up by $10 rather than $5. But if we actually look at the percent change that represents, if our $10 was 100%, then our $5 is 50%. Then our new cost is going to be 150%. So if we look at the large tube, our $20 tube was 100%. Our $10 tube is 50%. So the 20 and the 10 will give us 150%. So in terms of absolute change, they went up by different amounts. So $5 for the small and $10 for the large. But in terms of percent change, they both increased by half their price. Or they're both at 150% of their original price. So what I'd like you to do is, having listened to this discussion, answer these questions. So now let's take a look at a couple of ways to think about percent increase and decrease. We have an example here where we're selling cereal, and it's a 20-ounce box. So these are ounces, and this is percent. 20-ounce box, that was the original box of cereal. That was our 100%. And now it is sold in 23-ounce boxes. So how much did it go up by in ounces? So we can say it went up by 3 ounces. But how much did it go up by in percent, or percent increase? And that's what we really need to figure out. So let's see if we can figure out what 3 ounces is in terms of percent. First, just to make sense of this diagram and this problem, so I could figure out that 10 ounces is 50%. I could say that 5 ounces is 25%. 1 ounce is 5%. And we went up 3 ounces. So we should be able to say that we went up 15%. This would be 115%. Right? So we were able to calculate this relative change based on what we already knew about the absolute change. Now that we've made sense of this, let's see. Calculate the increase in the weight of a cereal box as a percentage of the original weight. So we want to know the increase as a percentage of the original weight, which is this part that we found out. So 3 ounces is 15% of original price. Now, calculate the new weight of brand A box of cereal as a percent of the original price. We calculated the new price there. So that is 115% of the original price. And then it says subtract 100, and we get 15%. Why is it that we get 15% here and 15% here? Well, if you look at it, we're adding some increase. On the right side, we're adding 3 ounces. On the left side, we're adding 15%. That change is the same. We're just expressing it in different ways. So in the first question, we decided to calculate the change first and then express it as a percent of the original price. In the second question, we calculated the new price as a percent of the original price and then subtracted out the original price. So what's left is the change. There were 20 gallons of gas in a tank. Now there are only 15. Calculate the decrease in the amount of gas in the tank as a percentage of the original. Well, do we know what the decrease was in terms of gallons? We can easily calculate that. As a percent, we need to figure out what the 100% is and then see if we can make a related calculation. So we started with 100%. And our question now is, what is 15 gallons? We can use our number sense and say, well, if 20 is 100%, then 10 is 50%, and 5 is 25%. So 15 gallons would be 75%. So how far down did it go in terms of percents from 100 to 75? It went minus 25%. So calculate the decrease in the amount of gas in the tank as a percent of the original, 25% of original amount. Now calculate the new amount as a percent of the original. They're asking us to calculate that amount. So we said that was 75% and subtract it from the 100. So we would get 25%. The 100% is the original volume. We're subtracting 75, which is the new volume, and we see that the change is 25%. Why are those two things the same? In the first situation, we calculated the -5 with the decrease in the amount of gas in the tank, and then expressed that as a percent. In the second situation, we expressed the new amount of gas in the tank as a percent, and then saw what the percent difference is. In Activity 7R, we're going to just spend a little bit more time giving ourselves practice in using different models for calculating percent. So just as before, I'm going to ask you to answer the question using the percent thermometer and also using the model that the textbook is asking you to use. The price of a loungy chair was $400. The price of the chair has just gone up by 20%. So it says to complete the table, but we're going to try and make sense of it using the percent thermometer. The price of a loungy chair is $400 and it went up by 20%. And the question is, how much is the loungy chair now? So if it was a $400, that was our original price, and that was 100%. And it went up by 20%, so we would end up at 120%. And we want to know what that blank is, or what is the new price of the loungy chair. Well, let's see if we need 20%. Well, 20 is a fifth, so a fifth of 400 is 80. So the 20% that went up is actually plus 80. So this should be $480. So that was an increase, the price, increase in price. Let's look at number 2. A set of sheets was $60 and it's a 15% sale. So if the original was 100, we're going to go down 15%. So we're going to end up at 85, and we want to know how much that cost. See, we want 15%, so we can do 10% is 6, and 5% is 3. So 15% is 9. So we want to go down by $9, and that's 51. The price of a suit just went up by 20%. The new price after the increase is 180. Again, we have dollars and percents. The suit went up by 20%. So we had 100% and it went up by 20%. And what we know is the new price after the increase is 180. And we want to figure out what this is. We need to know how much this increase was in dollars. So 20% is a fifth of 100, but we don't know how much that was in dollars. But we know that it's a sixth of 120. So that would be $30. So this went up by $30. That means that it started off at 150. I'm going to leave this for you to answer and make sense of in your own words. And explain why you can't calculate the price of the same suit before the increase by decreasing 180 by 20%. What would happen if we did? If we set that to be 100, because we're decreasing 180 by 20%, then 20% would be a fifth of that. And what is a fifth of 180? $36? So what would happen if we go down by 20%, we're going to go down by $36, and you know that that is not the same as what we were doing in the first example. We said that we went up by 30. So what's the problem? Why what's happening is that here we found out it went up $30, but if we calculate it in the opposite direction, we're saying $36. $30 versus $36. I'm going to ask you to make sense of that in your own words. And then also to do question 4. So now let's look at some student analysis. So the price of cruise increased by 15%. The new price is $2,300. What was the price before the increase? So first of all, let's make sense of the situation for ourselves. The price and percent. The price of a cruise increased by 15%. So it used to be 100. Now it's 115. It went up by 15%. The new price is $2,300. And the question is, what was the old price? So let's see how Matt solved the problem. First, he found 10%, and that is $230. So the 10% of what is $230? It's 10% of $2,300. Then 5% is half of that. Again, 5% of 2,300 is half of that. So 15% of 2,300 is 345. So I took 345 away from 2,300, which leaves 1955. And now I'm going to ask you to write what you think about Matt's solution in the answer. I'd like you to think about whether the 10% of 2,300 is what we're doing here. If we did in fact find 10%, would it be of the 2,300? And I think you will notice that the percent is actually of the old price. That wasn't 2,300. So your 10% should actually be less than $230. Whoopie-doo makeup used to be sold in 4-ounce tubes. Now it's sold in 5-ounce tubes for the same price. Ashley says the label should read 25% more, whereas Carolyn thinks that it should read 20% more. Who is right and who is wrong? So if we set it up again, we have ounces and percents, and it used to be sold in 4-ounce bottles, and now it's sold in 5-ounce bottles. We know that this went up by 1 ounce, and the question is, how much did it go up by in percents? I'd like you to think about who is right and who is wrong and why. The film club increased by 15 members to 45 members. Amy says that that's a 300% increase. Kaya says it's 200% increase. Who's right and who is wrong? So if we have members and percent, it went from 15 to 45, so it went up by 30 members. And the question again is, what is this? So Amy thinks that that's 300% increase, and Kaya thinks that it's a 200% increase, and I'd like you to explain who you think is right and why. So let's look at the examples here in Activity 7T. At first, Prairie had 10% more than the cost of a computer game. After Prairie spent $7.50, she had 15% less than the cost of the computer game. How much did the computer game cost, and how much money did Prairie have at first? Explain your reasoning. The book is asking you to use the strip diagram, so go ahead and do that. But we're also going to use the percent thermometer. Prairie was buying a computer game, and she's talking about dollars, and she's also talking about percents. So at first, she had 10% more than the cost of the computer game. So there's a cost of the computer game, and she had 10% more. After Prairie spent $7.50, she had 15% less. So from here to here, she spent $7.50, and now she has 15% left, so she's at 85%. We need to figure out how much the computer game cost. We know that whatever she had, when she spent $7.50, she now has less than the computer. And we know that that's $7.50. Do we know anything about the drop in percent from 110% to 85%? Well, we can figure out that that's an overall 25% drop. So we know that $7.50 is 25%. If 25% is $7.50, then what's 100%? 25% is a quarter of 100%, so we can multiply by 4 to get 100%. So that should be $30. The computer game cost $30. So notice this is a non-standard percent problem, but using the percent thermometer and the strip diagram that you can do on your own using the textbook, they can figure it out quite nicely. One mouse weighs 20% more than another mouse. Together the two mice weigh 66 grams. How much does each mouse weigh? Explain your reasoning. Let's set up the percent thermometer, and it seems like we have grams and percents. And one mouse weighs 120% of the other mouse. So this is mouse 1, this is mouse 2. This is 100, this is 120. Together, the two mice weigh 66 grams. So together, how many percent will that be if you put one mouse together with a second mouse? Wouldn't it be 220%? Be more than twice of the first mouse? And together they weigh 66 grams. So I think that based on this, we can figure out how much each of the mice weighs. Because if we know 220% is 66 grams, then we can figure out that 10% is 3 grams, right? Dividing by 22. Then we know mouse 1 is going to be 30 grams. And we know mouse 2 is going to be 36 grams. Now let's make sure that together they weigh 66 grams. I'm going to ask you to explain your reasoning. I'm going to leave question 3 for you to figure out. And finally, let's look at the percent problems and the commutative property of multiplication. So we looked already at where we had this situation, that we had to be very careful about what we looked at as 100%. if you set the original price to be 100 and the new price to be 115, that would make a very different problem, different calculation than if you looked at the current price as your 100%. So this becomes even more important when you're solving problems like this. Which, if either of the following two options, will result in a lower price for a pair of pants? The price of the pants is marked up by 10% and then marked down by 20% from the increased price, versus the price of the pants is marked down by 20% and then marked up by 10% of the discounted price. So let's see what happens if we have two situations, and in both situations we have price of pants. So this is our 100%. First situation, we mark up by 10% and then mark down by 20% from the increased price. So 20% marked down, but 20% of 110. So what is a fifth of 110? Notice that we're switching holes here. We're switching what the 100% is. So what is 20% of 110, or a fifth? Well, a fifth of 100 is 20, and a fifth of 10 is 2. So that should go down 22%. It's 18 from there. Then it should be 88. What if we go down by 20% first? So that will take us to 80. And then we go up by 10% of the discounted price. What's 10% of 80? And that's 8. So we'll go up to 88. So notice by switching the order of the discounts or the increases, we're not actually switching the final value. So if we have a number of changes in order, the commutative property continues to be applicable. So we can calculate either the 10% up or the 20% down in either order. So for number 2, suppose the pants cost $50 to start, and calculate what those two different discounts and increases in price would result in, and see if you can explain how the 0.8 times 1.1 times 50 and 1.1 times 0.8 times 50 relate to the question that we were talking about.